Array lists. Array lists are objects that store multiple values just like arrays, but with two main differences. The big difference is arrays, well, they're both big differences. Array lists can be resized, so after you've made the array list, you can change it by adding or removing items. Array lists can only hold objects, so that's why we learned about wrappers, because we can't make an array list of int, but we can make an array list of integer. Import for array lists. Import java.util.ArrayList. Creating an array list that can hold any object type. ArrayList name equals new ArrayList. An example would be ArrayList rectangles equals new ArrayList. There's a problem with doing it this way. I just want you all to see that you can do it this way. But the problem is array lists created in this way store any item added to them as an object. If we add rectangles to our list, it will store them as type object. And when we retrieve those rectangles, they're given back as objects. We would then have to cast them back into rectangles before we could use the rectangle methods. So this gets complicated. If you have an array list of people, make an array list of people. If you have an array list of rectangles, make an array list of rectangles instead of making a generic array list. So we're going to move on to the next slide. I'm going to show you how to make an array list of a specified type. Creating an array list of a set type. Array list, angle bracket, whatever type you want, so whatever object type, angle bracket. Name equals array list, angle bracket, object type, angle bracket, parenthesis, parenthesis. An example of that would be array list. I left off the y there. So instead of ARRA list, it should be array list, angle bracket, integers, nums equals new array list, angle bracket, integer. So I have an array list that can only hold things of type integer. I can't put strings in it. I can't put rectangles in it. I can only put integers into it. The methods, there are a lot of methods that we're going to go over. So we're going to go through those slides and then do a couple examples. Int size returns the number of elements the array currently stores. E bracket bracket to array returns all elements in the array. Now notice I put E. That's kind of weird. What the E is whatever type we specify. For example, in our last one we specified integer. So if you did the to array, it would give you back an array of integer. And when you do E get, this is going to be integer get int index. Returns the element at the specified index. Remove, when you send it an index, there are two removes. But if you call remove and you send it an index, it removes and returns the item at the given index. So if we had a list of strings and we say remove the third string, it would send back the text at that location. We have set. You send it an index and a value. What it does, it replaces the item at the given index and returns the old value that used to be there. So if my string, if I had an array list of strings Bob, Jim, Ted, and I said set 1 to Jimbo, it was Bob, Jim, Ted, so Jim was at the middle, and that's location 1. It would change Jim to Jimbo, and it would return Jim. Boolean remove E value. This one goes and hunts down for a specific value, and it removes the first occurrence. For example, again, if we had, forgot what my list was. Let's say Billy, Jim, Ted. And if we wanted to remove Jim, we'd say remove, quote, Jim, quote. It would go hunt in the list looking for Jim. When it finds it, it would remove it. This method returns true if it successfully found and removed the value. If it was unable to find the value, it returns false. And again, remember, it removes the first occurrence, not every occurrence of the value. So if you had 15 gems, after you call remove gem, you'd have 14 gems. Boolean contains. It returns true if the given value is in the list or not. Boolean add. We don't really care about the Boolean. It adds the value to the end of the list. We have add at an index. This can be used to insert. If we add at location 2, all the items from the item at location 3 would shift over to position 4, making room for it. It's not replacing like set, it drops it into the list. And we'll see examples of this in the next slides. Void clear destroys all the items in the list. It drops everything from the list. Int index of value returns the first index that has the value that you sent. It'll return -1 if it cannot find that value, just like index of with string. Boolean is empty. Returns true if the size of the list is 0 and false otherwise. Example 1. So I'm going to draw this out. I'm going to need a pen. So if I add 5, my list would be 5. If I add 6, this adds it to the end, 5, 6. If I add 7 at the end, I would get 5, 6, 7. Now if I add 188, that means right here we're going to put in 88. My list is now 5, 88, 6, 7, because this used to be at 0, this used to be 1, this used to be 2. And when I put 88 in at position 1, let's put boxes around the indexes for us, this guy is going to have to be shifted over to 2 to make room for the 88. This guy is going to have to be shifted to 3. Now let's run through the output. So, output. On one line, we print numbers. It's going to automatically know that it's going to put a bracket, 5, 8, 8, 6, 7. And we get commas. So it always, when you call it, it has a toString already. That makes everything look beautiful. Now numbers remove 3. Even though it's storing integers, I'm actually sending an int to remove. So it's going to do the remove that goes by location, because I'm sending an int, not an integer. So I'm going to location 3, which is right here, and I'm removing it. Remember, this will return what gets taken from the list. 7. System.out.print numbers set 0 to 15. So I'm going to go to spot 0 and change it to 15, and it will print out the value it used to be, which is 5. Numbers.get2. 0, 1, 2. It'll print 6. And if I print off the list, we'll get an updated form of the list, which was 15, 88, and 6. Alright, we're going to move on to the next slide. This is just a note to you. Let me move it so you can see the exclamation. Do not remove items in a for each. If you remove elements during a for each loop, it will crash your program. So if you have to remove items from a list and you have to go through to find it, then do it with a for loop, not a for each loop. Attempting to remove all the values of 5. So we know we have to do it with a for loop. So let's just say that, okay, nums is 2. Oh, remove all values above 5. 2, 7, 9, 3. Just like on a test, I'm going to use my paper, and I'm going to walk through this piece by piece. This is at 0, this is at 1, this is at 2, this is at 3. X equal 0. Is that less than num.size? Num.size is currently 4. So yes. And so you might be saying, well, it says 0, 1, 2, 3. Remember, it's like an array. There are 4 items there. The last one happens to be at position 3. Okay, if the item at position X is bigger than 5, remove X. Is 2 bigger than 5? Nope. X gets bigger, becomes a 1. So, is the 1 at position 1 bigger than 5? Yes. So we destroy this value by removing it. X goes to a 2. But look, our index has changed when we cause that remove. 9 is now at 1, and 3 is at 2. Is the item at position 2 bigger than 5? Nope. When we go down here to print our list, our output's going to be 2, 9, 3. this loop failed to remove all the occurrences of all the numbers that are greater than 5. On a test, I will ask a question like this. Be ready for it. Here's how we correctly remove all the values. So 2, 7, 9, 7 looks a little weird, so let's make it better. 7, 9, 3. Again, x equals 0. Is 0 less than size? Yup. Is that a number bigger than 5? Nope. X changes. 1. Is that bigger than 5? Yes. So we do two things. We remove it, and then we make x smaller. We push it back down the list. So x becomes 0, so then when we get up to the plus plus, it becomes 1, rechecking the thing at spot 1, because now that's a 9. Is 9 bigger than 5? Yes. So we destroy it. We mark this out. We go back down to 0, because we always move back 1 if we remove something. Then we go up to 1, which would be the 3. We check the 3. It's not bigger than 5. We get to 2. Is 2 less than the size, which is 2? No. So now we can print. Now we print 2 and 3. This correctly removed all the items that we were trying to destroy. And that's it.